Alright, so welcome to this amazing video. In this video, we are going to discuss what we call refraction of light at plane surface. Okay, and under this, we shall look at refractive index, refractive index, refractive index, and we look at what we call Snell's law. Snell's law. But before we begin, if you are new to our channel, I want you to smash the red subscribe button, share the video, comment, and like the video. Okay, so let us proceed. Light will continue to travel in a straight line in as much we have a single medium or a material. This phenomenon of light traveling in a straight line is what we call the rectilinear propagation of light. Rectilinear propagation of light, okay, meaning the idea of light traveling in a straight line if we have a single medium or a single material. But the story will change when we have a pair of media. If I have two medium, the story will change. When light travels from one medium into another medium, the speed of light will change. Okay? The change in the speed of light will bring about what we call the bending in the light ray. Okay? Either towards the normal or away from the normal. This bending of light ray is what we call refraction. Okay, so we define refraction as the bending of light ray. Bending of light ray when it travels from one medium to another. So let's write it. Refraction is defined. Refraction is defined as the bending of ray of light when it travels from one medium into another medium of different optical densities. Different optical densities. So when we hear the word optical has to do with what now? Light. Okay? Now, so this is refraction. So this bending of light is what we term what now? Refraction. So this light can either bend towards the normal or away from the what now? Normal. So in the next phase, we are going to discuss what we call bending of light and what we call refractive what now? Index. So let's just write. Bending of light and refractive index. This is just what now? Definition of what now? Of refraction. Refraction is defined as the bending of ray of light when it travels from one medium into another medium of different optical what now? Density. Different optical what now? Density. So the change in speed is what causes what now? The bending of what now? Of light. So now, how does this light bend? That's the next thing we want to work now. Discuss. How does the light bend? So bending of light, and refractive index. Bending of light and refractive index. Now, we have two cases here. Case one. We can have a case whereby the light ray will travel from an optically less dense medium into an optically more dense medium. So from less dense, the ray of light, a ray traveling from an optically less dense medium, e.g. I want to use water here, e.g. water to an optically more dense medium, more dense medium, more dense medium, e.g. let's say what now? Glass. Now, class, take note. In this video, we are going to be using water and what now? And glass. Glass is denser than water. Water is denser than what now? Than air. So these are the three things we are going to be using in case study in this video. So now, when a ray of light travels from what now? An optically less dense medium, take note of these, to an optically more dense medium. What happens to the ray as it strikes the surface of what now? Of separation of the medium. So we have this. So this is the first medium that we call medium one, which is what now? Which is water in this case, water in this case, water. Okay, and we have medium two, which is what now? Glass. So this is the less dense medium. This is the what now? The more dense medium. So if ray of light travels from a less dense medium, okay, into a more dense medium, on entering this medium, this ray of light will bend towards the what now? Normal. This is what we call our incident ray. Okay, this is our what now? Our refracted ray, and this is our normal. Okay, so the angle between the normal and the incident ray in the first medium is what we call angle of what now? Incidence. Angle between the normal and the refracted ray in the second medium is what we call angle of what now? Refraction. Now class, look at this. We have incident ray in water. Okay, we have incident ray in water. So I can label this one what now? I water, because we have incident ray in what now? In water. I can label this one what now? RG, because we have refracted ray in what now? In glass. So the angle of incidence is in water. The angle of refraction is in what now? Is in glass. So they can ask us that whenever a ray of light travels from a less dense medium into a more dense medium, what happens to the ray of light as it enters the second medium? What happens? Once it's coming from what now? Less dense to more dense, the ray will bend towards the normal. Take note of that. When a ray of light travels from what? A less dense medium into a more dense medium, the ray will bend towards the normal. Now look at this. This ray is supposed to be traveling like this. Okay, are you with me? So what happens? It bends to this place. So here we're going to have what we call angle of what now? Deviation. It bends to this place. It bends. Okay? Now, this is our angle of what now? Our angle of deviation plus our angle of what now? Refraction. We give us what? Our angle of incidence. Look at this. From geometry, what about there? We have this thing forming what now? S shape. Look at this, and this. So it means our what now? Our angle of incidence in water will be equal to what now? Our angle of refraction in glass plus angle of what now? Angle of deviation. So whenever they ask us to calculate what now? Angle of deviation for this case, make D the sort of formula. Our D because of what now? Angle of incidence in water minus what now? Angle of refraction in glass. You can just say angle of incidence in the first medium minus angle of refraction in the second medium. Now, what we call refractive index. Refractive index is the essence, the measure of the essence to which this ray will bend when it enters the second medium. Are you with me? The refractive index of a pair of media is a measure of the extent to which the ray will bend as it enters the second medium. And this refractive index is given as the ratio of the absolute refractive indices of the pair of media. So we use N for refractive index. We are still on case one. Okay, we use N for refractive index. So pay attention here now. Pay attention here now. What is refractive index? We said refractive index is the extent to which a ray of light will bend. Is a measure of the extent of bending of ray of light as it enters what now? A medium coming from one medium. And this refractive index of a pair of media is given as what now? Ratio of their absolute refractive indices. So here, because we have refraction in glass, we say glass with respect to water. Take note of this. Because we have refraction in glass, we first talk about what now? Refractive index of glass, okay, with respect to water. This can be called the refractive index of glass with respect to water, or the refractive index of water to glass. And what is the definition? It is the ratio. It is the ratio of the absolute refractive indices of this what now? Medium. So we have our NG all over what now? NW. Take note of this. Okay? Take note of this. The refractive index of what? Of glass with respect to water is equal to the ratio of the absolute refractive indices of what now? Of glass and what now? And water. What is now absolute refractive index? What is now absolute refractive index? Absolute refractive index. Absolute refractive index. Absolute refractive index. Absolute refractive index. Now, whenever we compare the refractive index of a medium or a material with that of air, we call that in absolute refractive what now? Index. Okay? So the refractive index of glass with respect to air is absolute refractive index. The refractive index of water with respect to air is absolute. So I can put what now? Air here. I can put what here? Air here. Are you with me? So we said what now? The refractive index of a pair of media is the ratio of their absolute refractive what now? Indices. So what is now absolute refractive index? When you compare the refractive index of a material with respect with that of air, we have what we call absolute refractive what now? Index. So we define absolute refractive index. Absolute refractive index, is it okay like this? We define absolute refractive index, okay, of a medium as this. So suppose we have refractive index of glass, absolute, is equal to speed of light in air all over speed of light in glass. Speed of light in air all over speed of light in glass. This is glass. I want us to take note of all these formulas. They are very important as we are going to use them to solve what now? Question. Take note of the way I'm naming all these things. They are very important. This is glass with respect to water, or water to glass. Okay? This is glass with respect to air, which is absolute refractive index. This is water with respect to air, which is what now? Absolute what? Refractive index. So how do you define absolute refractive index? It is the ratio of the speed of light in air to the speed of light in the material. And what material are we using here? We are using glass. So we define the refractive index of what now? Of glass, which respect to the air is equal to speed in air all over speed of light in what now? In glass. So take note of this. Okay? What of the refractive index of what now? Of water, which respect to what? To air, which is absolute. Is that not? It is absolute. So we have absolute refractive index of water, which respect to the air is equal to speed in air all over speed in water. Speed in air all over speed in water. So this is how to define what now? Refractive index in terms of speed. This one now is refractive index in terms of refractive indices. So this is definition of what now? Refractive index in terms of refractive indices. Refractive indices. Is it okay here? Refractive what? Indices. Refractive indices. So, but here, this is how to define what now? Refractive index in terms of speed. In terms of speed, this is refractive index definition in terms of speed. In terms of what? Of speed. Okay? So we've done 2 here. Are you with me? Now, see what is happening. See what is happening. If I divide the average refractive index of glass with that of water, what would I have? Let us do. If I divide what now? The average refractive index of glass with that of water, what would I have? So here, I'm going to wipe this one off. Alright, so we have this. Average of brightness of glass all over average brightness of water will give us speed of light in air all over speed of light in glass divided by speed of light in air all over speed of light in what now? In water. So what do we have here? We have our VA all over VG times VW all over V what? VG. So what happened? VW all over VA. So what happened? This VA will cancel what? This VA. So this will not give us what now? VW all over VG. This is the pattern of what? Of glass all over out of what now? Water. This one here is the same thing as saying what now? The refractiveness of what now? Of glass with respect to water. This thing here. Okay, glass all over water is what now? The refractiveness of what? Of glass with respect to what now? To water. And this will give us speed in water all over speed in what now? In glass. So, in summary, for now, we add 2. In summary, for now, we have the refractiveness of glass with respect to water is equal to, in terms of what? Refractive indices, it will be N of G all over N of what now? W, which is equal to, in terms of speed in water all over speed in what now? In glass. It therefore implies that what now? Refractive index is inversely proportional to what now? To the speed of light. So we have N inversely proportional to what now? To the speed. From what we have here. Look at this. Ng over W is equal to what now? VW over what now? All over VG. Inverse relationship between them and there. So this is what we have. Take note. So I've given the summary of the formula. So if that question under refractive indices, we use this. If that question under speed, we use this. But recall that speed is equal to what now? Frequency times what? Times wavelength. Speed equals frequency times wavelength. So it implies that what now? Our speed in air. Let's look for speed in air. Speed in air will be equal to what now? Frequency in air, then wavelength in what? In air. Speed in water will be equal to what now? Wavelength in water, then frequency in what now? In water. Then speed in glass will be frequency in glass multiplied by what now? Wavelength in glass. So I want to give us a formula of refractive index in terms of wavelength. So that's what we're trying to do here. So let us go. So let us wipe this one off. We know that what? The speed of light, refractive index of glass, with respect to water, is equal to speed in water all over speed in what now? In glass. What is speed in water? That will be wavelength, frequency in water, wavelength in water, all over. What is speed in glass? That will be frequency in glass, then wavelength in what now? In glass. But note class, the frequency of light traveling from one medium to another medium does not change. That frequency is constant. It is only the speed and the wavelength that will be affected. So the speed and wavelength will be affected, but the frequency is unaltered. So here we can say our what? Our FW equals to what now? FG, which is equal to what now? F. So here we have F lambda W all over F lambda G. So what happened? F becomes what now? F. So the refractiveness of glass compared to water in terms of wavelength is equal to wavelength in water all over wavelength in glass. So I'll put it here equals to wavelength in water all over wavelength in glass. Are you with me? Is it okay in this space? Alright, so we have three formula for refractive index. We can define refractive index in terms of refractive indices. We can define refractive index in terms of what now? Speed. We can equally define refractive index in terms of what now? Wavelength. So any of these can go depending on the question given. So here we are going to solve some questions before we move ahead. And take note. It means from here, refractive index is inverse proportional to what now? To speed. Refractive index is inverse proportional to what now? To wavelength. But speed is directly proportional to what now? To wavelength. If I'm given medium 1, medium 2, it's very simple. Suppose we have medium 2 to 1. Okay, medium 2 to 1. This will be what now? Refractiveness of what now? 2 all over refractiveness of what now? Of 1. Absolute refractive indices. It will be equals to WB1 all over B2. It will be equals to what now? Lambda 1 all over lambda 2. If we are given question in terms of what now? Medium 2 with respect to medium 1. This one is called the refractiveness of medium 2 with respect to medium 1. See the way I'm laying more emphasis on it, because I know that this is where the challenge is. That's why I'm trying to pronounce this one more and more. Refractiveness of what now? Of medium 2 with respect to medium 1 is equals to average refractiveness of medium 2 all over average refractiveness of medium 1, which can also be equals to what now? Speed in medium 1 all over speed in medium 2, which is also equals to what now? Wavelength of medium 1 all over wavelength of medium 2. So can use this formula to solve question under refractive index. So we're left with what now? Refractive index. Okay, I'm left with what now? The first case, which is when light travels from what now? Less dense to more dense. Okay, what happens to the ray? The ray of light will bend towards the normal. When light travels from what now? Less dense medium into a more dense medium, it will bend towards what? Towards the normal. What about if it travels from more dense into less dense? You must know all these things though, because they ask question on them. They ask question on them. So if it travels from what now? Look at this. The ray of light coming from glass to water. This one now is now what now? More dense to less dense. Because glass is dense than what now? Than water. Okay, it's denser than what? Than water. So here we have this. So what happens to the ray? The ray of light, the ray of light, okay, bends away from the normal. The ray of light bends away from the normal. So here we have incidence in glass. I'll put angle of incidence in what? In glass. Here we have refraction in water. I'll put angle of refraction in what now? In water. So what happens here? What happens here? So it means our refractiveness of water is less than glass. Okay, so here, first, what? Look at this. Look at this. We can ask us. We can ask us. Our angle of what now? Incidence in glass. Look at this. Is less than angle of incidence in what now? In water. Look at it very well. Look at it very well. You can say, the following is correct. When a ray of light, when angle of incidence in glass is less than angle of refraction in water, angle of refraction in water. So what happens? So it means the ray will bend away from the water now, from the normal. Take note of that. What about our refractive index? Refractive index of water, okay, is less than the refractive of what now? Of glass. Look at this. Refractive of water is 1.33. That of glass is 1.5. That of air is 1. So which implies the refractiveness of water is less than what now? The refractiveness of what now? Of glass. So if they say, what happened to a ray of light traveling from a medium with refractiveness of 2 to a medium with refractiveness of 5? What happened? It will bend away from the normal. To bend away from now, because refractiveness of what now? Of water here, water is less than what now? That of what now? Of glass. What about the speed? Speed of light. Speed of light. Speed of light in air is 3 times 10 per 8 meter per second. Speed of light in water is 2.25 times per what now? 8 meter per second. Speed of light in glass is 2 times 10 per what now? 8 meter per second. So in terms of speed, what can we say about the speed? The speed of light in water is greater than the speed of light in what now? In glass. Speed of light in water is greater than speed of light in what now? In glass. Take note. And we know that what now? Refractive index is inversely proportional to what now? To speed. This one, if this one is increasing, the speed will what now? Will decrease. Are you with me now? So these are the 3 things that can make the ray to bend away from the normal. They can ask us in terms of what now? Angle. That of what now? Refractive index, and in terms of what now? Speed. Why does this ray bend away from the normal? The first one is because the refractiveness of what now? Angle of incidence in glass is less than angle of refraction in what now? In water to bend away. Then the refractiveness of what now? Of water 1.33 is less than the refractiveness of what now? Of glass, which is what now? 1.5. The ray will bend away from the normal. If the speed of what now? Of water, which is second medium, is greater than the speed of what now? Glass, which is the first medium. It's also what? Bend away from the normal. Please, let me recap this. This one that we have here. We have a ray of light. Okay? Turning from medium 1 into medium 2. Okay? Now, the question will be like this. You know, we have N1 here as the refractiveness of the first medium. We have N2 here, which is the what now? Refractiveness of the second medium. We have now say if our N2, okay, is less than what? N1. Wow. If our N2, meaning the refractiveness of the second medium, is less than the refractiveness of the first medium. Look at what we have here. Second medium, which is water here, is less than what now? Refractiveness of what? Of glass, which is the first medium. What happened? The ray obviously will bend away from the normal. If the refractiveness of the second medium, pay attention, if the refractiveness of the second medium is less than the refractiveness of the first medium, the ray will bend away from the normal. But if the refractiveness of what now? Of the second medium is greater than the refractiveness of the what now? Of the first medium. This one is case 1. The ray will what now? Bend towards the what now? Towards the normal. From example, we have water to glass. This one is 1.33, okay, N of water, and N of glass is what now? 1.5. So if the value of the second medium, which is glass, is more than the refractiveness of the first medium, the ray will bend towards the what now? Towards the normal. Okay? So look at this. Look at this. Here too, we have what we call angle of deviation. We'll discuss the first one and second case, isn't it? The first case is a ray of light traveling from what now? From less dense to more dense. The ray will bend towards the normal. Second case is a ray of light traveling from what now? More dense to less dense to bend away from what now? From the normal. This ray is supposed to be traveling like this. This ray is supposed to be traveling like this. This ray, okay? What happens? It now bends to this place. So here we have what we call angle of what? Angle of deviation. Pay attention to this. Because they ask question under angle of deviation too. Yeah. Look at everything here is about now the angle of refraction. So I can have small angle here. Suppose I have one small angle here. Which is what now? Angle here. It implies that our angle of refraction in water will be equal to what now? S plus what now? Plus angle of deviation. D means angle of deviation. Angle of deviation. Angle of deviation. So what happens here? Look at this. Make this your formula. It means our D will be equal to what now? R W and what now? Minus X. But this our S is equal to what now? Angle of incidence in glass. Particular of these angles are what now? Are equal. So we have our S equals to what now? Angle of incidence in what? In glass. So change this one to this. We have our angle of division is equal to what now? R W minus what now? I W. Class, take note. The first one, take Case 1, where light is traveling from what now? Less dense to more dense. We have our angle of rotation to be equal to what now? I minus what now? Minus R. But in this case, we are having our angle of rotation to what now? R minus what now? Minus. This one is angle of rotation in what? In glass. Not in water. It should be in glass. Okay? So we have R minus what now? Minus I. The first case is I minus what now? Minus I. Are you with me now? So pay maximum attention to that. Case 3. I don't really ask more questions on this, but it's very important. If the ray is just normal to the surface, there won't be what now? No bending of light. If the ray strikes surface like this, that's what I'm saying. For case 3, if I have something like this, the ray case 3, the ray of light strikes the surface of separation of the pair of media normally. So here we have something like this medium, just go in straight like that. So these are normal. These are what now? Our angle of incident. Look at this incident ray on the normal. So one that is strikes the surface normally, making an angle of what now? Let it be the surface. Our angle of incident here equals to what? 0. Angle of refraction equals to what now? 0. So what happened today? The ray will just go into the what now? Into the second medium, straight like that. So there won't be what now? Bending here. The first case, the ray of light will bend. Second case, the ray of light will bend. But this third case, no bending of what now? Of light ray. As it moves from this medium into this medium. So that's what we have under what now? The nature of bending of light ray. How light ray bends? Either it bends towards the normal or away from the normal. Light ray will bend towards the normal. If it's coming from what now? Less dense medium into a more dense medium to bend towards the normal. But if light ray is coming from what now? More dense medium into a less dense medium to bend away from the normal. So we have that on that. So let us discuss the laws of what now? Of refraction. We have 2 laws of refraction. Okay? I won't clean this thing up to be like this because we can also define the refractive index in terms of second law of refraction that we call Snell's law. So let us read this one like this. Summary. We see about what now? Our NGW, meaning refractive index of what now? Of glass with respect to what? To water. Of glass with respect to what? To water. So here we have second medium with respect to what now? The first medium. So it could be glass to water, it could be glass to air, it could be water to air. You must be able to spot the second medium and the first medium. We have refraction in the second medium. Please take note of this. We have refraction in the second medium. We have incident ray in the first medium. And we have what now? Refracted ray in the second medium. So we pronounce this thing as refractive index of the second medium with respect to the first medium, or first to second. Is it clear? First to second, or second with respect to what now? To the first. So let's go to what now? Loss of refraction. Loss of refraction. Loss of refraction. Before we solve loss of refraction. So loss of refraction. Loss of refraction. Loss of refraction. The first law says that the incident ray, first law, the incident ray, the refracted ray, and the normal, at the point of incidence, all lie on the same plane. Okay, so we have our office. Now, the point at which the incident ray strikes the surface of separation of the media is what we call point of incidence. They ask the question. Look at this. Like this. This is the incident ray. This point is what we call the point of incidence. What is the point of incidence? That is the point at which the incident ray in the first medium strike the surface of separation. This is the surface of separation. So if I have air here, I have glass here. So this place is called air glass boundary. Air glass what? Boundary or air glass what now? Separation. Are you with me? Is it clear? So the point at which this incident ray in the first medium strikes surface of separation is what we call the point of incidence. So the law says the incident ray, the refracted ray, and the normal are the point of incidence all lie in the same place. Now, second law is where we are going. This law is very, very important. Very, very important. The second law says that what now? The ratio of the sine of angle of incidence, sine of angle of incidence to the sine of angle of refraction. Angle of refraction is a constant. Is a constant for a given pair of media. For a given pair of media. So that's the second law. Second law says that what now? The ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. This second law of refraction is called Snell's law. The answers that what is the other name for second law of refraction? It is called what? Snell's law. Snell spelled like this. Snell's law. So you say state Snell's law. Snell's law is the second law of what now? Of refraction. What is this law saying? Let us interpret it. Okay, just pause the video, take the laws down, because we are going to hear that thing very sweet now. Very, very sweet. Very, very sweet. Very, very sweet. Look at this. See what the law is saying. The law is saying that what now? Refractive index, which is equal to what now? Sine of angle of incidence all over sine of angle of refraction is a constant. The ratio of the sine of angle of incidence to the sine of angle of refraction is what? Is a constant. And that constant is what we call refractive index. That constant is what we call refractive index. Of what? Of the second medium with respect to the first medium. Look at this. You know I'm hammering on second medium to first because I've seen students making mistake in this one now, how to name refractive index. So I'm taking my time to hammer on the way we pronounce refractive index. It is called refractive index of the second medium with respect to the first medium. Where we have refraction, we will call that one first before the one we have now, incident. Are you with me now? So look at this. Suppose we have a diagram like this. Look at this. I want to extend this law. This is what we call Snell's law. Snell's law. Snell's law. Okay, ratio of angle, sine of angle of incidence to sine of angle of what now? Refraction is what we call refractive index. This is a constant. So suppose we have a diagram like this. We have this. We have this. We have this. I want to use air glass medium now. I put this one as what now? As air. I put this one as what now? As glass. Obviously, because the ray is coming from what now? Less dense medium into more dense, to bend towards the normal. Look at this. So let's assume the refractive index of air is given as what now? Na. The refractive index of glass is given as what now? Ng. Where do we have angle of incidence? We have angle of incidence in glass. Where do we have angle of refraction? We have angle of refraction in. We have angle of incidence in air. In air. And we have angle of refraction in what? In glass. Are you with me? This is our refracted ray. This is our what now? Incident ray. Now, we said here the refractive index of glass with respect to air. The way we pronounce this, refractive index of what? Of glass with respect to air is equal to, based on Snell's law, sine of angle of incidence. Where do you have angle of incidence? In air. All over sine of angle of refraction. Where do we have angle of refraction? In what? In glass. In glass. In glass. Are you okay? But we start the refractiveness of what now? Of glass, which equal to here is the same as N A G all over N A. You correct? Look at this. Dividing of what now? Of 2 to 1 is dividing of what? 2 all over dividing of what now? Of 1. So here, let me split this one now. This is 2 to 1. 2 to 1 to be refractiveness of what now? Of glass all over that of what now? Here is equals to sine of angle of incidence in what? In here all over sine of angle of refraction in glass. When we cross multiply, we have NA sine IA is equals to what? NG sine RG. So take note of this formula under Snell's law. So suppose I put this one as N1. I use N2 for this first medium, second medium. I use theta 1 for this. I use theta 2 for this. Then this one becomes N1 sine theta 1 is equals to what? N2 sine theta 2. This is what we call Snell's law. Are you with me? Because the media, they must have what now? Refractive index. So which look at this, look at the S the tree. Is this one the sign of this what? Angle. This one the sign of this what now? Angle as simple as that. The value of the first one multiplied by the sign of its own angle is equal to refraction of the second one multiplied by what now? Sign of its own what? Its own angle. So take note of this formula is very important. So here, if we can further define refractive index in that of what now? Snell's law, which will be equals to from here. So let me complete the formula. So now we are having the last one here. Is it okay here? So we have, let us write everything like this now. So N21, we have in terms of what? Refractive indices, absolute refractive index, we have what now? N2 over N1. In terms of speed, to be speed 1 over what now? Speed 2. In terms of wavelength, to be wavelength of 1 over wavelength of 2. In terms of Snell's law, it will be sine theta 1 all over sine theta 2. Where theta 1 is what now? The angle of incidence, and theta 2 is what now? Angle of refraction. So this is the complete version of refractive index. They can give us any question. Let them read the question. Any question given, you can use any of these. You can relate this with this. If the question involves refractive indices and speed, I'll use this. If the question involves refractive indices and wavelength, I'll use this and this. If the question involves refractive indices and sign of angle, I'll use this and this. So let us solve questions. Let us quickly solve some questions. Are you with me? If you enjoyed this video so far, please just subscribe, click the subscribe button, share the video, comment down, second box below, and like the video. Okay? So we are trying to do justice to what now what we call refraction at plane surface. This is the first video of this series. We have more coming. So let us go and solve some questions. So I will mark some off. These are basis for solving of questions. So everything under refraction is things. This is what we need. That's what we need. So let us go. Okay. Now, suppose we are given the absolute refractive indices of glass and water is 3 over 2 and 4 over 3. We are now asked to calculate the refractive index of a ray of light traveling from water to glass. Okay, from water to glass. So we are given the refractive index, absolute refractive index of water as 4 over 3. We are given the absolute refractive index of glass as 3 over 2. We now have to find absolute refractive index Find the brightness of glass with related to what now? To water. We don't know this. That's what we have to find. Excuse me. So we're given average brightness of water over 3, average brightness of glass 3 over 2. Find the refractiveness of glass with respect to water or water to glass. By the definition of what you have here, look at it. The refractiveness of what? Of glass with respect to water will be equals to the absolute refractiveness of what? Of glass all over the absolute refractiveness of what now? Of water. And this will give us glass is 3 over 2 divided by water is what now? Is 4 over what now? Over 3. So now because what now? 3 over 2 times 3 all over what? Over 4, which will give us what now? 9 over what now? Over 8. So what we have to find the refractiveness of what? Of water. With respect to glass, what should I mean? Refractiveness of what? Of water with respect to glass. This will be equals to what now? To be equals to refractiveness of what? Of water all over that of glass. Take note. If you want to define refractive what? Index in terms of absolute refractive index to be second all over first. Okay, second all over first. So what we shall give us? Out of water is what now? 4 over 3. So we have 4 over 3 divided by what now? 3 all over 2. So now be 4 over 3 times 2 all over what now? 3. So now because what now? 8 all over. They are not the same thing. You see that? You see that? So from here, I can bring in one thing that we call the law of reversibility of light. The law of reversibility of light. The law says when light rays are reversed, they follow the same path. A light ray follows the same path when what? When reversed. So it means from here, what I've done here now, I can say the refractive index of glass with respect to water is equal to 1 all over the refractive index of water with respect to what? To glass. This is what we call this thing here is what we call the principle of reversibility of light, which says when a light ray is reversed, it follows the same path. Because glass to water will give us 1 over water to glass. That is the first question. This is question 1. Question 1. Let's solve more question. Question 2. So here we solve question based on what now? Refractive index in terms of absolute refractive indices. Are you with me? Absolute refractive indices. So second one, let us solve this in terms of what now? Speed and refractive index. Speed and refractive index. Speed and refractive index. So look at this. Given the absolute refractive indices, okay, of water and glass as over 3 and 3 over 2 respectively. What is the speed of light in water? If the speed of light in glass is 2 times 10 to the power 8 meter per second. So here, we're given the absolute refractive indices of water and glass as over 3 and 3 over 2 respectively. We're asked to calculate what is the speed of light in water if the speed of light in glass is 2 times 10 to the 8 meter per second. This question involves refractive indices and what now? And speed. Which are you going to use? I will use this one and this. Okay? The one that contains refractive indices, absolute, with what now? With speed. So let us go. We also find the speed in what? In water. So here, we're given Ng as 3 over 2. We're given Nw as 4 over 3. We're given Vg as 2 times 10 to the power now 8 meter per second. And also find what now? Vw unknown. Speed of light in glass. Speed of light in what now? In water. This is the absolute refractiveness of glass. This is the absolute refractiveness of water. So what is the formula? Our what now? Our Ng. If you want to have W first, our Ngw is equals to speed of W all over speed of what? Of light. But what is this? 2 to 1. 2 to 1. No, this is 2 to 1. What will this one give us? To be N2 all over N1. As is, after dividing of glass to what now? All over the water is equals to speed in water all over speed in glass. From this. Look at this. Dividing of glass to water equals to what now? Ng over water. Ng. That's what I've done. Okay? The speed of light in water all over speed of light in glass is equals to the divided of glass divided to water. What is this one? It is ratio of the absolute divided of glass to water. So the question is solved. What I'm going to do just retilt. So what do I have here? What do I have here? So let's go. Ng is about 2 divided by our NW. NW is 4 over 3 is equals to VW, we don't know. VW, let us say this is X all over. VG is 2 times 10 to the power 8. What's the next thing? This will be 3 over 2 times 3 all over 4 is equals to X all over 2 times 10 to the power 8. It gives us what now? 9 over 8 is equals to X all over 2 times 10 to the power 8. What's the next thing? What's multiply? So here, we are having our S equals to this times this all over this. So now we are having 2 times 10 to the power 8 times 9 all over 8. What do I have here? 2 here 1. 2 here 1. No, 4. 4 in 9. This is 2 points. That is 8. 1. That is 2. That is 5. So times 10 to the power 1 now. It's per 8 meter per second. Please don't make that mistake. So we have 2.25 times 10 to the power 8 meter per second. This question involves refractive what now? Indices and speed. That was why I used this formula. The first one was what now? Refractive index only. Okay, and so is what? Refractive index is what now? It's P. That is the second question. Now look at this question, class. So we solve more questions. The more question we solve, the more we see how to use this one, the formula that I have here. Suppose we are given the angle of incidence of light in air at 60 degrees. It involves angle. I will go back to this. Are you with me? I will go back to this. Look at this diagram. Look at this diagram. Physics is very interesting. It involves concept, and that is what we teach in notice. We teach concept. Nobody does it better. Nobody does it better. Teach concept. Okay? With this, you don't need anything again. You don't need anything. Are you with me now? You don't need anything again. So let's go. So we have the look at this diagram. Look at this diagram. They give me 60 degrees here. 60 degrees here. This one is unknown. We are given the refractive index of this air 1 glass 3 over what? Over 2. We have to find what now? The angle of refraction in what? In glass. Okay? So what are we going to do here? I will just use what now? I will use this and this. That's what's that. So I'll be saying what now? Suppose I have this one to be 60. This is what now? This is unknown. I have NA1, NG1, 3, 1, 2. Mind you, we're interested to what? To here. So what do I have to do? So using this law, this involves what now? It involves angle. That will be N1 sin theta 1 equals to what now? N2 sin what? Theta what? Theta 2 is as far as that. What are N1? Out of what? Of air. That will be 1 times. What are air sin theta 1? What are theta 1? Theta 1 is what now? Angle of incidence in the first medium, which is what now? Sin 60. Okay? Is equals to. What are N2? Our N2 is what now? 3 over 2 times. Then we have sin what now? Sin RG. Sin RG. Our theta 2 is what now? Is angle of refraction in what? In glass. Are you with me? So we have this. What is sin theta? Sin theta is what now? 3 over 2. So we have 3 over 2. It's just what now? 3 over 2. Okay? Times what now? Sin what now? Sin RG. We have to find the sign of angle of refraction We have to find sine of angle of refraction. That's what we have to find. Find sine of angle of refraction. So what are we going to be having? What's the reply? So we're going to be having what now? Sine RG, which sine of angle of refraction will be equal to this times this 2 root 3. 2 root 3 all over what now? This times this. Look at this. Let's do it again. So I won't make a mistake. Let's go to multiply first. Here we have 2 root 3 all over 2 equals to what now? 3 sine what now? RG. So this times this 2 root 3 over 2. What's the next thing? By what now? By 3. So I'm dividing this one by what now? By what? By 3. By 3. So everything will become 2 root 3 all over 2 times what now? All over what now? 3 equals to what? Sine what? Sine RG. So what happened? This will cancel out this. So now that we know root 3 all over 3 equals to what now? Sine what? Sine RG. We also find the sine of angle of refraction in glass. To be like, but if you have to find angle of refraction, to now be what? To be sine inverse of what now? Of 3 all over 1 over 3. So that is the answer. You have to find angle of refraction. But here we are asked to find the sine of angle of refraction. Take note of the way we ask question. They say sine of angle of refraction to be like this. But they say find the angle of refraction in glass to be like this. Even if they don't ask us, take note now. We have angle of refraction in the second medium. That was why I put glass here. Are you with me? Then we have angle of incidence in the first medium, which is what now? Which is air. Are you with me now? So this is 60 and that is that. Now look at this. We are given angle of incidence as 60. Then the angle between the partially reflected ray and the refracted ray is what now? Is 90. We have to find the angle of refraction. Another question. So, can I turn off? Sure. But turn off. So, before I go, I'll do a recap of everything. Please make sure you subscribe to our YouTube channel. Share this video. Like it. Comment in the comments box below. Okay? So, look at this question. A ray of light is coming from this place. And the angle of incidence is 60 degrees. Okay? We know that what now? If we have a single medium, okay, light can travel in a straight line. We all agree. But if we have a pair of media, 3 things will happen. Not a pair of media, 3 things will happen. The light, part of the light will be reflected, part of the light will be refracted, and part of the light will be absorbed. Okay, so that's what I'm trying to explain in this question. So, partially reflected ray is this. Are you with me? You now said the angle between the refracted ray, and the partially reflected ray is 90. Find the angle of what? Of refraction. Find the angle of refraction. This is 5. And this is medium 1, this is medium 2. Medium 1, and this is what? Medium 2. Medium 2. Now, class, because the question involves angle, Snell's law is strongly suspected. You remember chemistry? That is strongly suspected. Snell's law is strongly suspected because it involves angle. Alright, so suppose I have this 90. Calculate this one. Let us add this one to be what now? Air, and this to be what now? To be glass. So let's go. We know that from the law of reflection, angle of incidence is equal to what now? Angle of what now? Refraction. So angle of reflection. Angle of incidence equals to angle of reflection. From law of reflection. I'm not talking about refraction now. I'm talking about what now? Law of reflection. Angle of incidence. Second law of reflection says angle of incidence equals to what now? Angle of reflection. So if one is 60, let's have our diagram here for the solution. If one is 60, OB of 50 should be what now? Is 60. Here, you have this. This face is what now? Is 90. If this one is 60, this is because of what now? 30. This one is 30, it will be what? 60. If this one is 60, this one because of what? 30 degrees. So, angle of refraction, I don't even need this here and glass. I don't need it. Just to confuse students. So, because of that, over parameter, over supplied parameter. So, here and glass, here, I don't need it. Okay, what I need to do is the analysis here. This one is 60. From angle of reflection, second law, this one will be 60. Everything here is what now is 90. Take it of that, please. This is 90. So this one is 60, so we got now 30. And because I said they are perpendicular, angle between reflected ray and refracted ray is 90. So this one is 630. This one we got now 60. Because 60 plus 30 equals what now? 90. Mind you, this ratio is what? Is 90. Okay? 60 is gone. What do we mean? We what now? 30. If they want to do something else, you can now say find the refractive index. So the first one, find the angle of refraction. That's the first one. And second one, find the what? The refractive index. Find the refractive index. Find the refractive index. So what I'm going to do, this one is 30 already. Because it involves angle, what would I do? The Snell's law will be applied. So I have N1 sin theta 1 equals what? N2 sin theta 1 2. So what do I have here? N1 is 1 of A 1 times sin 60 is equals to N2 is what I have to find. We don't know in our life. N2, which is what now? The refractive index of the second medium, which is glass. Okay? And then what now? What is sin theta 2? Angle of refraction, which is what now? We've done that, which is 30. I think we have 30. 30 for not flow, put 30 here. What's the next thing? By 30. Excuse me. By what now? By 30. By 30. So what do I have here? This will cancel out what now? This. What is the next thing? We are having our N2, which is the refractive index of the second medium, which is what now? First medium. Excuse me. Because what now? Sin 60 is what? 3 over 2. Whereby sin theta is what now? 1 over 2. Now we have been 3 over 2 times what now? 2 over 1. This will cancel out this. Our answer will be equal to then the last question for today. The last question for today. This one is technical but simple. Well, I'll tell you the way to do it. It's very simple. We ask question every year. You see it. They want to test our knowledge of what now? Complementary angle. Do you know how to relate geometry with physics? That's what this question is all about. Everyone is more. The same format. We're given this. We're given this. Okay? This place now, the one was past it. Say this place and this place is what? Is 90. I said, what is the refractive index? A, what is the refractive index? Oh, this medium, second medium. They put A tan theta, B cos theta, C cos theta all over tan theta, D they put ask sign of what now? This question. To find what now? The refractive index. So this is what now? Incident ray. This is what now? This is the reflected ray. This is what? Reflected ray. This is the refracted ray. Reflected ray. Partially reflected ray. This is what now? Refracted ray. So here, because of our half. But we know that what now? Our Snell's law. N equals to what now? Sin I or what now? Sin what? Sin R. Pay attention to this. Pay attention to this. Now, if the base is theta, okay, this is to be what now? Theta, based on the second law of reflection. So, this base is theta. I'll put my theta here. If the base is theta, this base is 90. This is a straight line. Are you with me? I want to solve it in another dimension. This is a straight line. See, from here to here, straight line. And what's some found in a straight line? 180. Isn't it? What I did the first thing, angle of incidence equals to angle of what now? Reflection from the second law of reflection. I put theta here. So this is theta 90. And this is my angle of what now? Refraction. That I don't know. If I know this one, I can create this one now, isn't it? So I know that my R is what? My 90 plus my theta must give me what now? 180. What's the reason? Sum of angles in straight line is what now? Is 180. So our R will be equals to what now? 180 minus what? 90 minus what now? Theta. To this side. To this side. So what do we have here? 90 minus what now? Minus theta. This is what? My R. That's my R. My R is 90 minus theta. So let me now use what? My Snell's law. I want to get what now? The refractive index of this medium. Second medium. It should be second medium. I think you know that. So what that one give us? That's the last thing for today. So second video is coming up very soon. So part 2 is coming up very soon. I mean sin theta all over. What is this? Sin 90 minus what? Theta. From complementary angle. Okay? From trigonometry, we have sin theta equals to what now? Cos 90 minus theta. We have cos theta equals to what now? Sin 90 minus what now? We have tan theta equals to what now? Cos 90 minus what? Minus theta. So as bonus. That is as bonus. So what is this? Sin 90 minus theta is what now? Is cos theta. So here I'm going to say sin theta all over cos theta. I will not stop here. What we call basic identity. So for every transform thing, it must be equal to what now? Sine of that thing all over cos of that thing from basic identity. So which implies sine of cos is what? Is tan. So the answer to this question is tan. If you enjoyed this video, kindly subscribe. Press the red subscribe button, share the video, like and comment. Part 2 is on the way. I remember saying, shalom. God bless you.